And now introducing a South Jersey production.
Good morning, man. It's Monday.
Let it know that 1, 2, 3 is on the microphone. I'm not running some junk that was a bad science project.
I'll get this party started here in a minute.
Built with skill, sweat, and blood. Johnny down the street thinks he has the heat, but when I key down the microphone, that sucker is gone. So get yourself together and do it right. Otherwise, you're not gonna get your name called tonight. So if you come across me across the band, you know I'm gonna wave a hand. I'll be screaming 1, 2, 3, South Jersey. Working my ball box, 24-pound, and my sight goes in.
A few minutes, let a few people slide in here, and we'll start this video. Should be good.
And now introducing. Let it know that 1, 2, 3 is on the microphone. I'm not running some junk that was a bad science project. This is a wicked machine built with skill, sweat, and blood. Johnny down the street thinks he has the heat, but when I key down the microphone, that sucker is gone. So get yourself together and do it right. Otherwise, you're not gonna get your name called tonight. So if you come across me across the band, you know I'm gonna wave a hand. I'll be screaming 1, 2, 3, South Jersey. Working my more watch, 24 pill, and my psycho zip driver. So if you wanna drop to the hammer, give it the best try. You watch your transistor spry, smell that smoke. I'm no joke. They call me Danny 1, 2, 3, South Jersey.
All right.
Let's see what's going on.
All righty, let's start this project. Let's get this going. A few more things to set up yet, but we'll be all right. So what we have going on here, good morning everybody. It is Monday morning. And this is 1, 2, 3 in South Jersey. This is who I am. A lot of you guys had seen what I've done. Some of you guys are new, some of you guys are old. Had a couple of interweb cowboys saying, oh, I don't do a very good introduction. Well, hi, my name is Danny. I'm 1, 2, 3, and I build amplifiers. So there's your introduction to South Jersey line. What's going on, Keith? How are you? Jeffrey, how are you? Good morning, good morning. So I built this unit, and the guy had got it. He had, I had to go all the way to 30 days on this. Actually, it was due on the 6th, and I just had so many dang things going on. But no problems. I communicated with the guy and told him I was going to be a bit late, and I actually had it done on the 6th, but you know, we're right on top of a weekend and everything else, and I didn't get around to the video. So with that said, this unit absolutely came out gorgeous. If you've seen some of the pre-pictures I posted up on Facebook, I kind of showed a little bit of the deck, the RF deck, and where I was setting at that time when I took the pictures. So now the unit's all complete, running beautifully, and we're going to talk about drive levels in this video. And it's important about drive levels and understanding where your maximum drive level is per transistor. Now, mind you, I talked about this, and I'll do it again. About these transistors, they are HG-2879s standards, I call them, because there is 4 chips inside of this component. So each chip is good for about 5 watts a piece. So that would say this transistor is good for a maximum of 20, and at around 21, 22, you're getting into the headroom. So the numbers I'm giving you guys are a little conservative for your own good. And if you decide to go beyond what I'm talking about, well, you'll see. The magical smoke will let the 10 ohm smoke out. It'll puff and blow. So this is 2879C here. It has 6 chips in there. So we're not going to be discussing that one. We're going to be discussing the standard 2879. That's what this is, made by HG. And they are a very good part, but you do yet have to mind your drive levels when you get into parts of any nature. You have to understand the specs on them. And if you're not, oh, I just squeezed a microphone and I just talk on the radio and I don't know nothing about all that, well, it's pretty simple. You pull out some math. So you'd pull out a calculator and let's just take and do a little bit of math. So if you're looking at this, you say, all right, I have, let's say, 200 watts of drive. Now, you have 200 watts of RMS power, not peak power, but RMS power. You're going to divide that 24 times. And that's only 8.33 watts per transistor, not per chip, but for the entire transistor. Now, if you want to understand where you're at on how many watts that is per chip, you just simply divide that number by 4 because there's 4 chips in here. So that's only 2.08 watts and a little after watts per drive. So if you get into, that's really low, knowing that you have the headroom all the way to 20 watts. So what do you think the performance is going to be at 200 watts of drive? Not very good. It'll work. It'll loaf right along. It might run like maybe a 12 pill or something like that, but we'll find out. What's going on, slow motion? Henry, how are you, sir? DJ Rock, what's up? So as you can see, these are really soft numbers as drive. Let's look at a maximum number. All right, so if I had 24 transistors and let's say I put 500 watts into this thing, and you divide that 24 times. That just put me right into my suggested drive level at maximum at 20 watts of transistor, and it's a little over. It's almost 21 watts. Bobby, how are you? James Gold, how are you? So we're at 20 watts of transistor at 500 watts of drive. I'm doing pretty good, Henry. So at 500 watts of drive, now you're filled this amplifier up. And we'll run that number again. Let's say you had 500 watts. You divide it 20, oops, clear that. Divide that 24 times. And it puts you back at 20 watts. So let's say, this shows you how fast this can change. We're at 20 point. So if we had 480 watts of drive, we're only going to drop 20 watts of drive. Divide that 24, where does that put us? That puts you right at the 20 watts of drive maximum. So if you're hitting 500, that extra 20 watts is going to put you at 500. It's going to put you up into, I'm going to overdrive this unit, especially on your voltage. Now I'm going to be doing this testing at 15.6 volts or so. So if you get involved into your voltage and say, oh, I have 14.2 or I have 13.8, you're not going to be able to drive this unit that hard because you can't fill it up. I kind of wish I had a smaller power supply at lower voltage where I could do this performance test for you, but I'm not too far out of the box, but I think it opens up my door for the peak a little bit more and drive as well when you have a little bit more voltage. But if you're stuck at 13.8 or 14.2 or 14.8 volts, you're just going to have to mind your drive, and you definitely don't want to get over this 20 mark. So, and that's at pretty much any level. You don't want to go over 20 watts of drive per transistor on the standard 2879s. So, let's take and push all this stuff to the side, and let's do a little show and tell. So, standard issue kind of up front. We got a little Psycho Zip quality control sticker ghosted in the background there. He's always in my boxes. I miss my little dog Zip. You guys, some people don't understand that, and other people do. So, at the back end of this thing, I have a huge slew cord keeper. I have six gauge wires coming out the back end of this one. Has a 1/2 inch ground bolt on the back end of it. And when you take this chassis off, because whoever gets my units from me, when I ship them, I pack them very, very well. And I want you to take the time, unpack them, keep your packing, put it away in a nice dry area, and then get it on a table with good lighting. Take all the screws out around the chassis. Do not take these 2 screws out back here because they hold a tuning bar inside, and peel the lid off of there. Now mind you, I always hook up my lids in the back here. The power wire is always in the back at the remote jack. So just lift the lid up like I do here in the video and just tip it off to the side. You can take the corner of the amplifier and the little leg, the little foot set on the inside right here, and that thing's not going to go anywhere. It's not going to tip over on you. So here's a regular standard business here inside of this unit. This is a 12 pill on this side, a 12 pill on that side, and then you have your 6-port combiner for the output over here, big relay in the back end, a big tuner bar, and then you have your standard business up front combiner. And there's really really not necessary to put a big brass tuner bar in here, so we did fixed capacitors. and our inductance coil. So there you go, there you have it. That's what we have inside this one. I kind of give it a little speckle. This is a 001 24 pill. No one has ever ordered a 24 with the standard 2879s in here, and this is the very first one. The guy actually owns a 16 pill that bought this one, and he liked it so much he wanted a 24. I kind of said you should go to a 32 and double down, but he said, nah, I'm just going to go with 24. So you're going to see probably about 1,000 watts for wherever you're at right now increase, and that's on the RMS side. So 800 to 1,000 watts of increase depending on your system and how you're driving it. So keep that in mind. On this unit, now this I was going to take and build in a 32 pill chassis, but I decided to change my mind since this one has to go halfway across the world and get landed over there in the desert. So I shrank down the cabinet size a little bit. This is a 24 pill cabinet. It does have 4 fans in it, and each fan is 108 CFM with filtration for the electrical. Right here, this little board, and then I filtered the air coming in with the dust covers on the outside of the unit, which those are washable. So description somebody asked for, I gave you all a really good one. All right, now let's get down to the brass tacks of this thing. Let's see how this thing is going to perform and what she's going to do. In the meantime, I'm going to turn on a few things, so sit tight. A lot of switches to turn on. All right, I think we've got this thing ready to rock. We are going to do this. Check 10, okay. All right, so here we go. Thank you all for taking and sticking through this for 13 minutes of an introduction, and we're going to get down to this unit. We're going to take and run Zippy. We're going to have them run it all the way down. I'm not going to make that 200 watts because I think my minimum is 300 on that one, without having to mess with my radio too much. Let's turn on one more item here. Let's turn on my tone. Let's get some frequency running through this thing. All right, we are ready to fly right there. All right, so throw a little carrier, or let's throw a little tone in here. Let's look at the slugs real quick. We're at a 25 watt slug here. What's going on, Albert? Try to make this a little bigger. All right, so we're looking at a 25 watt slug. Now this is a return slug, and it's coupled directly on my input of this amplifier. And this slug is, as you can see, facing where? Back towards my driver. All right, and that's going to show reflection, no differently if you had it on your antenna. So it's going to show the reflection and communications between this driver and the 24 pill. Now the jumper I have coming down from my radio, it's always a half a wavelength. That's right here going into the 5, and then I'm running a quarter wavelength out of the 5 into the 24, or 6 foot for layman's terms. Now I don't care what type of coax anybody wants to run. It don't make any difference to me, as long as you cut it to the right VOP, or velocity propagation, to frequency. And the only way you're going to be able to do that is actually with a stub tuner or a null tuner to trim your coax to the frequency that is desired that you want to talk on. So good rule of thumb, just cut for channel 20, and you're gonna get pretty close, higher or low to that. It's rare that you're gonna nail the number, but as long as you're in the same zip code, you'll be okay. So that is the input reflection going back to this box, and that will be on this meter right here. Now if I come over to here and I look at, I have a 1,000 watt slug. It's going to measure the drive power of the 5 pill or the Psycho Zip box. That'll be on this meter right here, input drive. Now coming out of this unit, and a couple different meter setups over here, and they're fairly easy. I'm going to be looking at, I'm not even going to bother with the 2500. We're going to move right into the 10,000 watt slug. We're going to show that in RMS and peak on the digital Dave. We'll use a 2500 here on the analog, and we'll use a 5000 on the analog as well. Now, I did test this on my Starduster, believe it or not. Hey, Molly. And didn't have no problems. That little antenna took it. I didn't beat on it. I just did some quick testing and showed me everything was really cool with my reflection on my antenna, and the boxes were running really good. Unfortunately, it wasn't no DX, otherwise I probably would have talked a little skip on it. But with that said, Big Mike in Florida, what's happening? With that said, let's take and fire this thing up. So we got, let's see how much drive we have going on in it. It's a 1,000 watt slug. Each line is 20 watts, and you're looking at the bottom scale. So we're producing a little over 300 watts of drive, almost 320, about 315, 310. So that's what we have going on there. Here's a 2500 analog. Showing about the same right there. Each line there is 50 watts. All right, and here's a 5 kilowatt. All right, the big hash mark's 500. So these slugs are, they're more accurate, more towards mid, half scale, sometimes a little past half. They're the most accurate there. That's what at least Bird says. All right, so firing this up, and I did have. I want to make a little note real quick. I want to make a little clause in this. I had guys bark and jump up and down for about 5 different text messages, or in the trend. I think it was a YouTube guy, and he said that I'm not setting a carrier. The reason why I'm not running a carrier when I'm running lower drive and I'm getting up to my full drive potential is because I constantly increase my drive level. So if I actually set a proper dead key at every time I keyed this video will be much longer. So with that said, I'm just going to set wherever it's at. I'm going to let it run, and we're going to keep it a little bit low until I get the full output power, and I'll set the proper amount of carrier, and I'll tell you why and when and why you need to set your carrier level where you're going to set it. And so that said, let me lower a few things. I got a tone going. Let me just see where I'm at. All right. Ain't got no carrier. All right, we'll give it a little. All right, we'll give it something. All right, it's low. That's 2,500 watt slug. Now let's take a look at my drive level again. Working. There is a working drive. So it allowed the power to come in. Why did it allow it a little bit more? We had it like set at 300. It's just because maybe the bypass isn't tuned properly, or I have to look at that one more time. But here that would be the transmit of the input reflection. So if I had a bypass, it bypasses up just a little bit, not much, but that's where it was holding power back when the driver's off. So if the big box is off, I'm at the 320 right there. All right, so that is what it is. That's the bypass on it. I can work on that. All right, so here's my drive, 300 watts, 320, and that 320 is producing on a 2,500 watt slug, top scale. Each line's 50. I'm doing it right around 2,200 on that. Let's see what the 5 kilowatt says. Each line's 100 watts there, so almost 2,150. And let's see what the 10 kilowatt says here. RMS. So 2,400 on that one. Now the peaker tweaker guys, this is where you love it. All right, here's your 4.9. That's almost 5,000 watts peak power with that little bit of drive. Now, if you take and pay attention, hello Eric, down in Florida. If you pay attention to peak, I just hit it with basically a minimum drive of 300, 320. So I'm at 14.7. If I roll this all the way back, I'm not going to have no carrier now, but let's just see what happened to my peak. It's still there. It's 4.8. Well, what happened to my RMS drive now? Back my radio way down. Now I'm doing at 200 watts of drive, input reflection. It's about 2 watts. That's pretty stable across the board. Here's the voltage we're running at, 15.6. But here's my peak, 4.9, 4.8. We'll have my RMS, 1.7. Up here, 2,500. So at 1,500 watts, it says it's 17 here. 5 kilowatt here, about 16. So they're all within reason. But that peak number is up there. And you don't have that much drive, about 200 watts. So if you're a peaker tweaker and you don't give anything here about RMS or don't understand RMS or average power, this is your filler. This fills up the transistor. So this number here, it's a free flow and go, happy-go-lucky number. It'll almost jump to full output power on peak at every power level that you put it at. Nothing wrong with the equipment. It's just how it works. All right, so as we increase our drive to fill up the RMS, now you're going to take and bring some body into the system. It's kind of like a stereo system. You could have all the highs you like, and they're always going to be there, but until you get some bass, it's not going to sound that good. So this RMS is, you can look as a filler as the bass in the system. This is going to give it the thump, the hit. I'm going to cut your lips off. You need RMS. This world does not run on peak. Peak power is always going to be there. It's a very important number to the guy that is designing it and to the guy that wants to take and see the happy-go-lucky number, because that number normally don't change. But the deviation and the changes are all made up from what the drive that you put into your unit. That's your RMS filler, because the peak is already there. So now we're just bringing the RMS up to try to match the peak, or you would never do that, but to take and fill into the system. Now, as you can see, I turned my radio way down. We're going to turn it back up. I wanted to see that 200 watt number before I could show you guys on the calculator. Alright, so we're back at 14.7 again. And let's see what our peak did. I didn't change anything else. 4.9. So it went up like 100, 200 watts. My RMS, my filler, went right back to that 320 mark. Now that 320 mark of my RMS filled it up. I went from 15, 1600 to 21, 2200 watts. That quick, by simply filling it up with drive. Now, let's fill up some more drive into this. Now we're making 2.4 kW an RMS, and our peaker tweaker should not change too much more from here on out. So, let's take a good look over here and take a walk. Take a microphone with me, because I'm sitting here looking at an amp meter and I didn't show it. Uh-oh. That did not work. Something was not working. Alright, I lost something. Bear with me. Something had quit. Decided to mess up. That's no good. Well, apparently my relay decided to mess up on me. Better here than there. Let's hold it up. Bear with me, guys. Got a problem here for some reason. I got an issue. Damn it. Haven't had that happen in a long time. Alright. Well, unfortunately I have a malfunction. I don't know how to fix it yet. For some reason something's not coming down. It's not actuating right on the relay. There. Something sporadic here. He's trying, but it ain't going. Well, got an issue. Let me see if I can just clamp it down, because I don't need it to actuate. I can fix the relay later. Maybe see if we can get power out of it, bypassing the keying circuit. Sit the phone down. Well, that's a rare thing that happened. It does happen though. Better here than there. I'm still ain't getting power across. There, got it. Alright. Well, I'm going to have to take a look at that. But in the meantime, I'm making power. Okay. So, moving on. Let me try to figure out how to get a lid on this thing some way. Shorten some stuff up. Do apologize, this does happen. Good news is I know the guy that built this thing. hook up a little something with the seat on the relay. I have to take a look at that. Alright, so sorry about that little malfunction. Didn't happen. I haven't had one of that happen to me on a lot of years on a video. Alright, so let's see where we left off at. Got a little bit of drive here. Alright, so turn that back. There we go, here's our drive. We're back at 300 watts, 320 or so. Input reflections hanging out a little bit under 2. And again, my peaker tweaker is at 4.9, and I'm doing a little over 2,000 watts RMS. Alright, that's cool. Nothing wrong with that. Now let's take and turn this thing up. Oh, I was going to show you the amperage. That's where we left off at. Alright, so right now we're at 284 amps at this voltage right here. 15.6, the box is running really nice. So if I turn my drive up, and I'm afraid to shut it off, but we'll see what happens. Alright, so there's about 400 watts of drive right there. A little over. It's 420. Alright, there's about 400 watts of drive. Alright, good, we're still working. Alright, 400 watts of drive now. Okay, amperage, we should have increased. 312. Input reflection. It actually went down. She's starting to sing a little bit. She went down. There's your output power. Now we're at about 23, 24. And we're hanging out right about the same over here. Take a look at the RMS down here. That's a 400 watts of drive. And we're at 2.7 RMS. And the peak of tweaker's at 5 kilowatts. Alright, that's at 400 watts of drive. So, if we take a look at the calculator again, we say we have 400, divide that 24 times, and now we're at 16.66 watts per transistor. Now if you want to say, oh, what is that per chip now? Divide that 4 more times, and now you're at 4.16 watts per chip. So, that's a pretty good number. You're not totally full yet. There's still a little bit of headroom, because where did I say we could go? If we went up to 480, all right, that'll put us right up into it perfectly, I think. At 20 watts, the maximum drive of these transistors. So let me see where the 420 comes in at. Or 480, I'm sorry. All right, there's 480 watts of drive. 500's at the big hash mark. Input reflection, what happened to you? Oh, it went down even more. It loves it. Alright, let's see what happened over here to the amp meter here. So now we're cooking with oil. We got 332 amps of power. The peak, I seen this thing flash and do something weird. I don't know why it's doing that. I don't know. Because it says it's a 10 kilowatt slug. This thing should not be blinking or nothing. Show me my power. Oh, there's the 10 kilowatts right there. I don't know why it's doing that. Couldn't even tell you. So, let's see if I change the slug, if that'd do anything different. .3. I don't know why it's kicking out like that. Don't have a clue, but I'll put the slug I had in here we've been testing with all along, and we'll just keep on going. I think my peak meter up here is dead. Oh, it's showing. Well, let's see if it works over here on this other slug. There's a 10 kilowatt peak on the analog. Alright, not trying to get too far off track here. That's a 10 kilowatt there. Yeah, it's showing me 51, 5200. Right there. Okay, so all in all, everything seems to be happy. I'm at 480 watts drive, and I'm at 20 watts transistor right now. So the performance on this thing is pretty much spot on. All right, 330 watts of amperage draw. To 480 watts of drive. What happens if I turn the drive up a little bit more and brought her up to 500? Let's see. There's your 500. Inputs are still happy. Peak is just flashing at me. It's mad. I don't know why it's doing that. What's analog doing? See, the peak is not increasing anymore, but my RMS is. Okay, so let's go back down here to RMS. We're showing 2.9. I don't know why it's blinking like that, but here is a 5 kilowatt analog right here, and it's showing me right at that 2600 watts. So that's how the standard pills work. Now, is that 20 watts? Is that for Toshibas? Yeah, you can do pretty much same for the Toshibas as well. You don't want to get too far out of the box, especially with the Toshibas, because you start breaking them, you're in bad bad shape there, Mike. No. But anyway, you cut it. It's just simply you're running a system, and if you're talking DX, you don't want to run it really this hard, just because you're going to take in you're going to kill the box. It's going to make a lot of heat. You're going to have a lot shorter talk time on it. But it is what it is. You have 24 transistors. A 16 transistor, you can still use a 5. And as you can see, my 5, I'm not even wide open. I still have a lot to go on this one. So it all depends on the voltage that you're running your radio on, the driver on, and all the rest of the above. Because I'm running this driver at 14.9. I'm putting a really hot radio into it, so I have to control it with the potentiometer, which is fine. And I don't mind to take and have a bigger driver as long as you understand how to control it. So bigger is not always better, but it's better if you're looking for control on your system. So that said, you got to work on this thing. This thing's been fighting me a little bit here. I don't know why, but I'm going to have to take a look at what's going on with the relay or the sniffer or the keying circuit, something of that nature. But right now I got it locked down. As you can see, I got it clamped to ground. Now it goes up and down. Let's see if we can make it go up and down again. It's in or out. It tries to work and then it don't work. So I might have to change that relay. I sure hate to have to do that. It's a lot of work. But I need to get on that before I can take and make sure she's 100% before I can ship it out of here today. So where is my girl? Hey Molly, you over here? Molly, come on over here. What's going on? How are you? How you doing? How's my girl doing? Look at you. Good morning, Molly. Hi. You can wave to everybody. Say good morning. It's Monday. Lazy day. We gotta fix your nose. Yeah, your nose is all messed up. Looks like you got sunburnt on it. Don't know why, because you ain't out in the sun that much, huh? You want a peanut? Here, look at that. You like the peanuts, don't you? Yeah? What do? You like, here, you gonna give me a wave? Yeah? How about a pretty? Oh, look at you. You're such a good girl, Molly. There you go. All right, there you go. Get your little peanuts, little Pac-Man girl. So, that said, it looks like I gotta turn my soldering iron on and take a look at why this relay decided to take and give me the mess up, but it might be something just hanging up on it and be easy fix. So, the length of coax that we feed these systems are very, very important. And there's guys out there that swears up and down it makes no difference. Those are the guys that aren't getting their name called. They can barely talk. They sound muffly. They sound nasally, and their equipment's not going to last that long, no matter who builds it for them. So don't blame your builder, whoever it is, because of your shortcomings, because your coax is 3 foot or 2 foot, or don't matter what length it is. All of this stuff matters. That's why coax companies spend thousands and thousands of dollars doing research and development on coax, and takes the time to give you a PDF on all the specification of what materials it's made out of, how it works, what frequencies it works on, what ohmage it is, all the above. Coax is very important because it transports the power from here through that piece of coaxial line to your antenna. And if you have this line the wrong length and you tune your antenna with the wrong length coax, you just detuned your antenna for whatever frequency it is because it's trying to match the coax. You probably never hit the 1.0. You're oh, I got a 1.2 or 1.3 because you didn't measure your coax properly and all it out. So you'll never get an antenna system tuned up properly unless you tune up your coax properly. Keep that in mind, guys. It's all part of it. Like I said in the previous video, it's no differently than going buying a Mako 7-element beam and just put it together and say, oh, that looks good. Don't measure a thing, just eyeball it and put it up in the air and start talking or try to talk on it. It's not going to be tuned. It's not going to be the resonant frequency, and that's what this is all about. Frequency. This is RF therapy is what we're doing here, and this is what I'm trying to explain. Each one of these amplifiers has to be tuned to the frequency that we're transmitting on. And then yes, it is a little wide banded if you make it that way, but if you look at the networks that I put in here, they're not very wide banded. They're pretty narrow banded, but they will cover the 1 through 40 channels for the most part. So a lot of times I'll ask the guys, what frequency do you talk on the most? Because that's where I'll tune these amplifiers up. When I have these multiple stage amplifiers, I'll tune these networks up to where they're going to be at that frequency and etc. So with all of that said, this is all frequency controlled stuff, and if you don't get to the close frequency that you're transmitting on, then you will not have any control on what's going to happen with your equipment. If it's going to run good or bad, most likely it's going to run poorly. It'll run, but it'll run very poor, and you're not going to see the performance out of it, and then you're going to push it and push it and push it, and then you're going to break it. I've seen it happen 1,000 times. I'm not going to say 1,000,000 because I haven't. I have seen it at least 1,000 times. People make mistakes and they put on the wrong coax, they hook up the wrong things, and their equipment just don't work. It fails. So, and again, this is a brand new unit, and unfortunately I'm having a failure for some reason with this relay. I don't understand why yet, but I will take and sort it out. So that said, guys, I'm going to slide out of here. Take care. It is Monday and it's already been a rough morning, and this here, I'm kind of glad you broke here instead of over there, wherever you're going. But I'll take and sort through this and we'll give it 100%. So there you go, guys. Take care. Thanks for watching RF Therapy, South Jersey 123 Productions. I'm sliding to the left. Molly's already out of here. I think she's wanting to go potty. So y'all take care. Have a wonderful day. I'm sliding up out of here. Oh, there's Molly. There you are. You gonna say goodbye? Molly, you wave bye-bye. Yeah. Oh, you're such a good girl. Thanks for watching. There you go. Peanuts everywhere, Molly. Go and get them. They're all over there. They're everywhere. Look at them. Find them. Get them, Molly. All right, guys. Thanks for watching again. I'm sliding out of here. God bless. All right, guys, thanks for watching. I'm out of here. See y'all down in the Carolinas.